So the question 5, thanks, eyes up. Question 5, Superman is flying at an initial velocity of 33.5 metres when he decides to slow to 10 metres per second squared in a time of 8.05. That there represents part 1. Okay, and part 1 is probably the hardest part of this question to find. So again, same process, write down what we know. We knew VI, we knew VF, and we knew T, and we're looking for D. Now, unfortunately, because we've only got 3 rather than 4, learning the 4 kinematics equations off by heart, before we start, we need to actually find A. Because both of our equations with D in it also have A in it. So we need to find A first. Okay, so we did that using VF equals VI plus AT. We rearranged to find that A was negative 2.92 metres per second squared. And then from there, you can use any one of your equations with D in it. Okay, so over here I've done to the side, D equals VIT plus AT squared divided by 2. Sub my values in, and I found that D1 equals 175.04 metres. I've done some rounding, so your answer might be a little bit different. Okay. Alternatively, you could have used VF squared equals VI squared plus 2AD. Okay. 10 equals 10 squared equals 33.5 squared plus 2 times negative 2.92D. Just be very aware that that negative sign is being multiplied through. There is a multiplication present between the 2.92 and the D. So you need to ensure that when you're rearranging, so I think most of us got the subtraction of the first term, but some of us divided by or subtracted added 5.84 rather than dividing by negative 5.84. So just be very aware of that misconception, and that found us a distance of 175.04. Very similar to the top one. We then moved to part 2. So part 2 says, he then continues at his velocity for 12.4 seconds. Heaps of information there. We have a time. So we know that T, I didn't write that down, but we know that T equals 12.4, and we know that velocity, final and initial, is 10 because there's no acceleration present. So because there's no acceleration present, the VI equals VF. So we don't need to account for that. The really smart cookies in the room just said, well, distance equals speed times time, or displacement equals velocity times time, and found that 10 times 12.4 is 124 metres. That was D2. Part 3, probably easier than part 2, because we've now got an acceleration, VF and VI. So it says that before he travels at that velocity for 12.4 seconds before accelerating at 2.35 metres per second until he reaches a final velocity of 23.8. So again, because we've got VF, VI and A, we're looking for D. The only equation we should be thinking about using is VF squared equals VI squared plus 2AD. We sub our values in, rearrange, and find that D3 equals 99.24. The question says what was his total distance or displacement. So D total equals D1 plus D2 plus D3. We sub in D1 as 175.04 plus 124 plus 99.24, and we get, what do we get? 300.28. Perfect. Meters. Okay. Now for question B. So question B says what was his average velocity? My hint is you probably need to use this number, and there's one time that is not stated in the question that you need to find. So for part 1 and part 2, our time is stated very clearly. You might need to think about your time in part 3. Okay, and then average velocity equals displacement over time. Good luck.